Hello guys, my name is Balkrishna Srivastava and welcome to Code with PK. So in this video, we write a Java code to multiply two matrices. So before we begin, it is a request to please subscribe to my channel because out of 100 viewers, only 2 to 3 are subscribed. More than 95% of my audience is not subscribed, and a subscription is very important. So please do subscribe to my channel. Also, one more thing before we start is that I teach coding in Hindi on a separate Code with BK Hindi channel. So this Code with BK English channel was the first that I started in 2018, and then I had requests through these years to teach coding in Hindi if possible. So I started this separate Code with BK Hindi channel. So if you people are comfortable with Hindi, it is a request if you guys could spare 5 minutes, check this channel out, let me know your reviews and thoughts about this channel. Alright, so we have to write Java code to multiply two matrices. So first I am going to explain you what is the process that goes behind multiplying two matrices, and then we replicate that process in our code. If you people already know how to multiply two matrices, you can skip to the part where I'm actually writing the code. I'm actually using the logic from the concept and applying it into our code. You can go to that part. Okay, so let's just understand what is a multiplication of two matrices. So if I have a matrix A and I have a matrix B, say m1 into n1, that's the dimension, m2 into n2, that's the dimension, number of rows, number of columns, number of rows, number of columns. Okay, so the multiplication of A into B, say product P, A into B, multiplication of two matrices is only possible if number of columns from the first matrix is equal to number of rows for the second matrix. That is, this is possible only if n1 equal to m2. Okay, this has to be the case, otherwise the multiplication won't be possible. Okay, now let's take an example to see how this actually happens. So if I have a matrix 1 2 3 4 5 6, okay, so it has 2 rows 3 columns. Okay, it is multiplied by another matrix 1 2 3 4 5 6, it has 3 rows 2 columns. Okay, multiplication is possible because this value, which is the number of columns of the first matrix, is equal to this value, which is the number of rows for the second matrix. Okay, so the dimension of the resultant matrix is going to be the number of rows in the first matrix, number of columns in the second matrix. So this is going to be 2 into 2. So the resultant dimension is m1 into n2. m1 into n2 is the, so matrix P is m1 into n2. Okay, which is A into B. All right, now how do we go about multiplying this? So this is 2 into 2, so this has 4 elements. Okay, rows 0 1 2 0 1, column 0 1 2, rows 0 1 2, column 0 1, rows 0 1, column 0 1. So you have 4 places to fill. We need to generate 4 values, one for each of these locations. So the value at this location 0 0 is basically these values correspondingly multiplied by these values. What do I mean by this is the value here is corresponding multiplication of these three values, that is 1 into 1 plus 2 into 3 plus 3 into 5. So 1 into 1 plus 2 into 3 plus 3 into 5 is going to be 1 plus 6 plus 15. This is going to be 22. So this is 22. Okay, similarly the value at this location is again same this row multiply with the next column correspondingly. Okay, the values are multiplied, the corresponding values are multiplied. So 1 into 2 plus 2 into 4 plus 3 into 6. Okay, so value here is 1 into 2 plus 2 into 4, okay, plus 3 into 6. Okay, so 2 plus 8 plus 18, so this is going to be 28. So this is 28. Okay, now this value is going to be moving on to the next row, which is this row into this column. Okay, so how do you multiply a row into a column? Is you basically multiply corresponding values. 4 into 1, so this is going to be 4 into 1 plus 5 into 3, yeah, first column, right? 5 into 3 plus 6 into 5, 6 into 5, this is going to be 4 plus 15 plus 30, 45, 49, this is going to be 49. And for the last value, second row into second column. Okay, so 4 into 2, so this is going to be 4 into 2, 4 into 2, 5 into 4 plus 5 into 4 plus 6 into 6, 6 into 6. Okay, 8 plus 5 is 20 plus 6 is a 36. So 28 plus 36 is 64. So this is 64. Okay, so for a matrix A, m1 into n1 multiplied with matrix B, m2 into n2, matrix multiplication is possible only if n1 number of columns in the first matrix equal to m2 number of rows in the second matrix. Okay, The dimension of the resultant matrix is going to be m1 into n2, number of rows in the first matrix in the into number of columns in the second matrix. How do you get these values? You multiply rows and columns. So first row into first column gives this value, first row into second column gives this value, second row into first column gives this value, second row into second column gives this value. Okay, how do we do this in our code? So in our code, matrices are stored as 2D arrays. So if I have the same matrix A, it will be stored as a 2D array with 2 rows and 3 columns. Okay, indices 0, 1, 2 for the column, index 0, 1 for the rows. We have values 1, 2, 3, 4, 5, 6. This is a 2D array. Okay, A. Okay, similarly, we will have B as a 2D array. Okay, this will have 3 rows and 2 columns. Column 0, 1, row 0, 1, 2. So values are 1, 2, 3, 4, 5 and 6. Okay, so if we are given two matrices A and B, and this is 2 into 3 and 3 into 2, these two values match, so multiplication is possible. So using these two values, number of rows in the first matrix, number of columns in the second matrix, you can create the empty resultant matrix, which is going to be 2 into 2. All right, so we can do this in the code. Okay, so we can say int m1, number of rows in the first matrix is a dot length, int n1, number of columns in the first matrix. Okay, similarly int m2, okay, is b dot length, int n2 is b of 0 dot length. Okay, you can add a check to see if multiplication is not possible, that is if n1 not equal to m2, you return null. Okay, so null is returned if the multiplication is not possible, and that's what we saw, that n1 and m2 have to be equal. Okay, so now that we have the dimensions of the two matrices, we can create the product matrix. Okay, so the dimensions are going to be m1 into n2. So I'll say int p is new int m1 into n2. Okay, and finally you have to return the product. All right, we have to do this part to calculate the product. Okay, replicate our multiplication process into the code. Okay, so what was happening is we are multiplying this by this to get the value here, then we are multiplying this by this to get the value here, then we are multiplying the second row into the first column to get the value here, and then we are multiplying second row into second column to get the value here. Okay, so since we are iterating rows, my I is going to iterate rows of the first matrix, my J is going to iterate columns of the second matrix. Okay, because the idea is to multiply ith row with jth column, multiply ith row with jth column. Okay, and a multiplication is basically multiplying the corresponding values and adding them up. Okay, when I say this, I takes values 0 and 1, and j for each value of each value of I takes 0, 1, 0, 1. So the pairs of ij generated are 0, 0, 0, 1, 1, 0 and 1, 1. Okay, which are the 4 locations of the resulting matrix. Okay, P. All right, so when I iterates the rows of the first matrix, j iterates the columns of the second matrix, ij combination will give me all the locations that I need to fill in my resultant matrix. Okay, now I need to fill this. So what do? I take another variable k that iterates these three values, that is k iterates. Okay, the same k will iterate 1 columns of first matrix. Okay, for given row I. Okay, for this row I have 3 columns, and k is gonna take indices for all 3 columns. Okay, so k takes 0, 1, 2. At the same time, the same set of values of k 0, 1, 2 are also the row indices for the second matrix. Okay, so rows of second matrix for given column j. Okay, because I is iterating the rows of first matrix, j is iterating the columns of the second matrix. Combination of ij is what we need to fill this location ij in the product. Okay, so when k takes index values to iterate these three columns, the same k also iterates these three rows. Okay, so for each ij, okay, I will have for each ij k will be 0 1 2, k will be 0 1 2, k will be 0 1 2, k will be 0 1 2. Okay, so apart from the usual ij nested loop, the third level of nesting will be k taking 0 1 2, that is iterating three times, which is basically n1 or m2. Okay, so we have for int I equal to 0, I less than m1 I plus plus. For each value of I, we have j taking the columns of the second matrix. We have j taking the columns of the second matrix. So second matrix has n2 columns, n2 j plus plus. And for each ij, I will have k that will iterate these many times, which is columns of the first matrix or rows of the second matrix, because n1 and m2 are equal, so you can do k less than n1 or k less than m2. So I'll do n1 k plus plus. Okay, the same as doing m2. Okay, either. Okay, all right. Now since k is able to iterate these corresponding values, I can multiply them. I can say this into this plus this into this plus this into this. So this particular value is going to be a of this row, and k is taking the column, and this value is going to be b of this row, which is k, and column is j. Okay, so a of ik into b of kj is the product of these two values. Then k moves forward to the next index. So a of ik is now this value, b of kj is now this value, these two are multiplied. Then k moves on to the next index. So a of ik is this value, b of kj is this value. Okay, so you say you have to find the sum of products of the corresponding values. You start with 0. You say x plus equal to a of ik into b of kj. Okay, and this resulting value will go into ij location of p. So you say p ij is x. Okay, and you return the product, which is p. Okay, and this is your code. All right, so I have written some code to print the matrix, and I've also taken two matrices 1 2 3 4 5 6, 1 2 3 4 5 6. All right, the way we have in our examples. Okay, so I'm going to say int p, my product is going to be multiply the matrices a b. Okay, so I'm going to print matrix a, okay, the name of the matrix, and change a line. Then I'm going to print b, name of the matrix, and change a line. Okay, b in this case, and then I'm going to print the product, which is a into b, and this is my p. Okay, running this, I get 22 28 49 64, which is 22 28 49 64. Okay, all right, let's take a simple example. It's 1 2 3 4 and 5 6 7 8. Okay, okay, so this so this is this into this. So 1 into 5 plus 7 into 14 plus 5 19. This into this is going to be 1 to 1 6 6 8 to the 16 plus 6 22. Now this into this is going to be 15 plus 28. 15 plus 28 is going to be 43, and this into this is going to be 6 is 18 plus 32. 32 plus 18 is going to be 50. So if I have a b now as, commenting this out, 1 2 and 3 4. Okay, a is 1 2 3 4, b is 5 6 7 8. Okay, so this should give us 19 22 43 50, which is what we saw. Okay, all right, this is how you multiply two matrices. Okay, and we also added a check. If the multiplication is not possible, we return null. So the return value, if null, basically signifies that multiplication is not possible. Okay, all right, so this was the video, and I hope this was helpful. So if there is any doubt, there's a part you do not understand, please let me know in the comments. I always try to answer all your comments. You can also let me know in the comments if there's a question you want to solve or if the concept you want to discuss. So please like this video, subscribe to my channel, and thank you for watching.